To put it in simpler words, we take a combination of these header fields with specific values and we define that as a pattern, okay, for a flow. So whenever there is a packet coming in, the SDN router is essentially determining which flow the packet belongs to, because that flow entry is going to tell the SDN router how to handle the packet. That is called the generalized forwarding. So step number 1, the most important step. For each incoming packet, take the header. Try to match the various patterns, okay, in the flow table. If there's a matching entry, go to the action column, so that's step 2, and then handle the packet that way. It could be simply to forward the packet to the next router, or drop in the packet, or modify the packet, or send the packet to the remote controller. So that is usually for debugging purpose, by the way. And step 3, increment the counter so that we track number of packets matching to the flow, number of bytes, okay, matching to the flow. Now, priority. Yeah, so this is something that we have not yet talked about, the priority column. Okay, so the flow table should have actually 4 columns instead of 3. Let me explain why we need priority there. Yeah, these patterns, okay, in the flow table. Some of these patterns could be more coarse-grained. Many of the packets might match the pattern. Some might be finer-grained. Okay, few packets will match the pattern. So if we have multiple patterns that are coarse-grained, chances is actually high that they overlap. Okay, therefore, for a packet incoming, that packet could potentially match to multiple patterns, multiple entries, and each entry specifies an action. So, which actions do we take then, right? So priority there, okay, is to specify which pattern carries a higher priority and which one carries less. So we could differentiate or break the tie among all the matching patterns. Which one should be taken priority, therefore we take the action, okay, in the prioritized entry. Okay, so priority there is to disambiguate all the matching entries. Now in traditional forwarding, we don't need to specify a priority. Why? Traditional forwarding there is to do what? Prefix matching. We do have multiple prefixes existing in the forwarding table. So one packet could actually match to multiple prefixes. Then, you know what? In traditional forwarding, we are also doing the longest prefix matching. That actually breaks the tie naturally, because there's only going to be one longest prefix. Okay? Unlike in SDN, we could have multiple patterns, and the patterns are now general, right? It's not always prefix, so you cannot use the lengths to break the tie. So we have a specific priority field there to break the tie. Okay, so the forward table in a router, 4 column, and it defines, okay, how the SDN handles a packet. It defines the match and action rules. To be more concrete, let's look into 3 examples. Now, in all 3 examples, we look at the source address and the destination address header fields. Now, in example number 1, we don't want to match the source address being 1.2. something. Okay, so the asterisk here meant wildcard, meaning arbitrary values for the last 2 octets. Destination address must match 3.4.5 for the first 3 octets, and then doesn't matter, okay, what the 4th octet is. Now, all packets matching this pattern will be dropped. In second example, source can be anything, but destination address needs to match 3.4. something. And then we forward all those packets to interface 2. Third entry, 10.1.2.3. As long as the source IP address is exactly this, we send the packet back to the remote controller. So 3 examples. You get a rough feeling. Now, let me come back here. I have not yet explained what OpenFlow means. Yeah, this is the data plane abstraction for SDN routers, all right. Okay, what does OpenFlow mean? Okay. OpenFlow, capital O, capital F. It's a very specific term. It is the protocol, okay, defined for communication between the data plane router to the control plane remote controller. Okay, so remote controller installing forwarding table using the OpenFlow protocol.